check timestamp of 17 with R timestamp and then W timestamp of Q. Timestamp of transaction 17 is 17. We should check it with R timestamp. R timestamp of Q is 16. 17 is not less than 16. So rejection condition does not satisfy. The next condition is checking with W timestamp. Timestamp of transaction 17 is 17. We check it with W timestamp of Q. W timestamp of Q is minus infinity. 17 is not less than minus infinity. So the second rejection condition does not hold. So write operation is not rejected and is executed successfully. And write timestamp of Q is updated to 17. Then let's check write Q operation of T16. For this operation, we should check if timestamp of 16 T16, which is 16, is less than R timestamp of Q. R timestamp of Q is 16. Okay. 16 is not less than 16. So the first condition does not satisfy, and this operation does not reject it. Is not rejected. Then we check the second condition. Second condition is checking the timestamp of T16, which is 16, and check if it is less than W timestamp of Q. W timestamp Q is 17. Okay, this condition is satisfied. So the operation is rejected. Why this operation is rejected? Because T16 wants to write Q, but before this operation, T17, which has a bigger timestamp, has written on Q. So T16 has come late, and write operation of T16 cannot be executed, because if this write is executed, the result of T17 is overwritten, and it is not permitted. The order should be according to timestamp. T17 has bigger timestamp, and its operation is executed before. We cannot let write operation of T16 is executed later. So this operation is rejected. So write is reject. Okay, any question?
توماس مقروء
I check the order of execution of this operation in this schedule according to timestamp ordering. According to timestamp ordering, write of T16 cannot be executed because it has come late. Rejected. But what about this schedule? If we had another schedule, T16, T17, read Q, write Q, write Q. Okay. In this case, again, read queue of T16 is executed successfully because no transaction with bigger timestamp has done a conflicting operation. Then we check write queue of T16. Write queue of T16 is also executed successfully because before before execution this operation, no conflicting operation has been done by a transaction that has bigger timestamp. So this operation is executed successfully. Then we check write queue of T17. It is also successfully executed because the previous the conflicting operation that has been done on queue previously are of transaction that has less timestamp than timestamp of T17. So the order of execution is correct. The conflicting operation of transaction that has less timestamp is executed first, and the operation and conflicting operation of timestamp that has bigger of transaction that has bigger timestamp has executed later. So the order of execution is okay, and the operation are executed successfully. Okay, if we compare these two schedules, we see that the difference is very little. In the left side, write operation of T17 is executed first, and then write operation of T16 is executed. In the right side, the write execution of T16 is written first, and then write operation of T17. So the difference is very little between these two schedules. In the right side, in the right side schedule, after T16 writes Q, immediately after this write operation, T17 writes on Q. So T17 overwrites the write of T16. So this is equal to this. It is equal to the situation that T16 has not written Q, because after T16 writes on Q, immediately T17 writes on Q, and no transaction can see the write of T16. So if T16 writes on Q or does not write on Q, there is no difference, because immediately after that T16 writes on Q. Okay, so in the right side we can ignore the write of T16. If we ignore the write of T16 and we omit this operation, it is not important, because the write of T16 immediately is overwritten by the write of T17. So this write operation is not important. We can ignore this write. So in the left side, we can do in the same way. Suppose the read operation of T16 is executed, then the write operation of T17 is executed, and the write operation of T16 wants to be done, but because it comes late, if we want to do this write operation, this write operation is rejected in the
Because
timestamp ordering. But we may assume that this write operation has come before write operation and write operation of T17, but we ignored this. So if the write operation of T16 comes late, again we can ignore it. And we can assume that it has come before the write operation of T17, but because it is not important, we has ignored it. So we can modify timestamp ordering according to this situation. If a write operation of a transaction comes late, we can ignore it, and this will be equal to the right side schedule, and no and it is not it does not matter, and no problem is occurred here. So by this modification, we can reduce the number of rollback of transaction. So the situation will be better than the original protocol. So we modify the protocol according to this explanation. If
timestamp ordering
transaction
right rule.
TI wants to do read Q A, we check W timestamp of Q, and we compare timestamp of TI with the W timestamp of Q. If timestamp of TI is less roll backed. Else read Q is executed and RTS of Q is set to maximum of RTS Q and TSTI. So this is exactly the same as timestamp ordering, exactly the same as original timestamp ordering. But write rule is modified. If TI wants to do write queue as the original timestamp ordering, we should check write queue with two conflicting operations, with read queue and with write queue. The first condition, at first we check timestamp of TI with RTS of Q. If timestamp of TI is less than RTS of Q, this means that before TI, before the write operation of TI, some operation with a bigger timestamp has read Q, and the write operation comes late, so should be rejected, and TI will be rollbacked. then
then
TI
TI فيها
is
rejected
roll
back.
backed. The second condition is in the second condition we compare timestamp of TI with WTS of Q. In the original timestamp ordering, in this case again we roll back TI, but in timestamp ordering with Thomas right rule, here we ignore the operation. Only we ignore the operation and continue processing the operations, and we do not roll back TI. If TSTI is less than WTS
WTS of
Q, this means that some transaction with a bigger timestamp has written on Q, and the right operation of TI has come late, but it is not important. We ignore it. Then we ignore write Q. Otherwise, if none of these conditions hold, we do the operation write Q is executed, and WTS of Q is updated and is set to TS TI. Okay, as you see, the only difference between timestamp ordering with Thomas right rule and the original timestamp ordering is part B of second rule. If part B of right rule, when we are going to write, the second condition has been changed, has been modified, and instead of rollbacking TI, we just ignore write operation, and this modification causes a little rollback of transactions. So this protocol has less rollbacks than the original timestamp ordering protocol. So it is an improvement according to the original timestamp ordering. Okay. So again, if we consider the schedules, this schedule on the left side cannot be executed by original timestamp ordering, but it can be executed. It can be run by timestamp ordering with Thomas rule. This schedule is not legal under original timestamp ordering, but it is legal under timestamp ordering with Thomas rule. I rewrite it here again. We have this schedule T16, T17 with Q, write Q, and write Q. And this schedule is not legal under original timestamp ordering, but it is legal under timestamp ordering with Thomas rule. Okay, as you see, this schedule, if this schedule or does this schedule conflict serializable or not?
conflict التداخل.
The question is that does this schedule or excuse me, is this schedule serializable or not?
conflict.
Conflict serializable, serializable. Is it conflict serializable or not? Can anybody answer this question? Nobody knows the answer.
Yes, Doctor. Conflict serializable.
Why?
Write, and read, write.
Okay, how we check conflict serializable? We make
Doctor, it's not conflict serializable because it's if you draw the graph, then it's produce a circle.
yes. Do you remember precedence graph?
Yes.
Precedence graph.
16 by
Transactions.
not
Yes,
and
transactions.
17 by other not. We get a read write from T16, so we have edges from T16 to 17, and then other one back from 17 to 16. So it's made a closed circle, so it's
Yes.
not serializable.
Yes. If you remember precedence graph is a graph whose node are transactions, okay, vertices are transactions, and we have some edges. If we have two conflicting serializable operation, we draw an edge from the former to the later. Here, read Q has conflict with write Q, okay? And read Q is executed before write Q. So there is an edge between T16 to T17. This edge is drawn because of these two conflicting operations, read Q and write Q. Read Q and write Q are conflicting. The operation of the conflicting operation of T16 is done before the conflicting operation of T17, so there is an edge from T16 to T17. Also, there is another conflict between write Q and write Q, between write Q of T17 and write Q of T16. But in this case, write Q of T17 is done before the write Q of T16. So from the former to the later, we should draw an edge. So we draw an edge between T17 to T16. This edge is drawn because of these two conflicting operations between write Q and write Q. So there is a cycle. There is a cycle in precedence graph. When you have a cycle in precedence graph, this means that this schedule is not equivalent to any serial schedule because the above age says that T16 should be run before T17, and the below age says that T17 should be executed before T16, and it is not possible. So we do not have any serial schedule that can be equal, can be equivalent to this concurrent schedule. As you see, if we are going to make this schedule serial, either we should move right queue of T17 to up, or we should move it to down. But we cannot move it up or down because we cannot move right queue up because there is a conflict with read operation. We cannot move it down because there is a conflict with write operation of T17, and the order of execution of conflicting operation cannot be changed. We cannot move it down or move it up, so it cannot be converted to a serial schedule. We cannot move it up, or we cannot move it down. So this schedule cannot be converted to serial schedule, as the precedence graph shows. So it is not conflict serializable. The answer is no. Okay. Okay. This schedule is not conflict serializable, but it is legal under timestamp ordering with Thomas rule. So Thomas rule allows schedules are executed which are not conflict serializable. So Thomas rule does not ensure conflict serializability. Thomas right.
Thomas right. Thomas
Rule. Excuse me. Rule does not ensure conflict serializability. This means that if a schedule obey the rule of Thomas right rule, the result may not be conflict serializable, but it ensures view serializability. This means that any schedule that is legal under Thomas right rule and obey the rule of Thomas right is view serializable. So also the result is not conflict serializable, but we can be sure that the result is view serializable. So anyway, it is serializable. So it is equivalent to serial schedules. So consistency is guaranteed. Is guaranteed. So by Thomas right rule, we have view serializability, and the resulted the resulted schedules are consistent, although they are not conflict serializable. Okay, this is the
حلو.
timestamp ordering with Thomas
الناس اللي ضمن
right
الفكرة
rule,
كان ريفيو
the variant of timestamp ordering protocol, which improves the original protocol by reducing the number of rollbacks. Okay, any question?
Excuse me, doctor, can you re-explain the view serializability in this example? Because I can't get it. How it can be view serializable if we work on the three condition we previously talked about, it's gonna be closed. At the first initial read, and then the updated write, and then the final write. How it can be view serializable? Can you explain that to me, please?
Yes. In view serializability, we should check three conditions. The first condition is I show that this concurrent schedule is equivalent to serial schedule T16, then T17. Consider this serial schedule T16, then T17. In the concurrent schedule, which we have here, what transaction reads the initial value of data items? T16
Yes.
reads the initial value. In this serial schedule, T16, T17, also T16 reads the initial value of Q, because this is the first transaction and the first operation of it is read Q. We can write it here. The serial we write it in the serial schedule here, T16, T17, read Q, write Q, then write Q. This is the serial schedule T16, T17. In this schedule, the reads from that write operation. Okay, in the concurrent schedule, there is no read operation that reads from a write operation, because we have only one read operation that reads the initial value. This read operation does not read from any write, does not see the result of any write. So we do not have any read operation that sees the result of a write operation here. Also in serial schedule, we do not have any read operation that reads from a write operation. So the second condition is okay, because it does not occur. Okay, no read operation. There is no read operation that reads from a write operation in both schedules. The third condition is that any transaction that writes the final value of a data item in one schedule should be the same in the other schedule. In the serial schedule, T16, T17, what transaction writes the final value?
T17.
T17, okay. T17
What
writes the final value on Q. T17 writes the final value on Q. In the concurrent schedule, we have here the write operation of T16, which comes after the write operation of T17, but we ignore it we do not do it, ignore. It is ignored, is ignored. So in practice, the last write operation is done by T17. So the final value of Q is written by T17, not by T16, because it is ignored in the Thomas rule version. So in this schedule also T17 writes the final value on Q. So three conditions of view serializability are satisfied by these two schedules. So these two schedules are view equivalent. This schedule is view equivalent of serial schedule, so it is view serializable. Okay. Any question?
No, thank you, doctor. So much.
Okay, this is the Thomas Wright rule variant of timestamp ordering, and as I explained it, it ensures view serializability, and it does not ensure conflict serializability, because as you see in this example, this protocol allows schedules that are not conflict serializable, but schedules are view serializable. Okay, let me talk about some other transactions. A category of timestamp ordering protocols are validation-based protocols. Validation-based protocols. Validation-based protocols are optimistic protocols. In the previous protocols, in the timestamp ordering protocol, when we are going to read or when we are going to write, first we check the condition. If the condition is okay, then we read or write. But if the condition is not okay, we do not read or write. We reject the operation and we roll back the transaction. So first we check the condition. If it is okay, then we do the operation. But in validation-based protocols, we do not check the conditions. We first do the operation. We assume there is no problem. We assume there is no problem that cause rollbacking of transaction. We do operation without checking the conditions, and we are optimistic, and we assume that all thing is okay. But in some points we check the condition, not before every operation. We do not check before every operation the conditions. We do operations without checking the condition, but in some points of execution of transaction, we check the condition to see if all things are okay or not. So these operations, these protocols have less overhead and improve the performance of the system, because we omit many checks. We do not do very check, and in some points just we check the conditions. So performance is improved. Okay, let me explain the protocol in detail. And these protocols are good for environment. These protocols are good for environments uh, that conflicts are little, and uh, in many cases, in, and in many cases there is no problem, and it is not. It is these protocols are not proper for environments that in which there are many conflicts. Uh, for example, suppose we have many read-only transaction. I means that suppose our transaction just wants to read. In this case, there is not any conflict. All the transaction that wants to read data items can read data items without any problem. So if all the transaction are read only, uh, we do not need to check any condition. Uh, Always they can successfully read data items. We cannot we do not need we, we we do not need to check any condition. So in environments that conflicts are little, we can use validation based protocols that has less checking than the, the other protocols. Okay, let me explain the details of the protocol. Um, in this protocol, ever every transaction has three phases. Uh, the first phase is read phase. Read phase. Okay, in this phase, transaction does all its operation except write operation. Write operation are ignored.
Execution,
Okay,
please.
during uh, this phase, uh, TI is executed. It reads data items. Uh, it uh, it performs or it does it perform it performs all write operations on temporary
Temporary.
local variables uh, without updates on database. Uh, this means that the read operations and computations are done, but write operation uh, does not executed is not executed on database.
Exclusion.
Write operations
Data.
only are done on temporally local variables and does not affect database. They do not update database. This is the first phase, read phase.
Second validate.
In the second phase, which is validation phase,
Validation phase.
okay, in the read phase, all the operations of transaction are executed except write operations. Write operations are done on local variables and do not affect database. After finishing all the operations of transaction, the read phase is finished and we go to validation phase. In the validation phase, we check if we can do updates of transaction on database or not. In this phase, we check, in validation phase, we check if we can do actual updates on database or not. We check if we update database, is consistency hold, is serializability hold or not. If there is a problem, if serializability cannot be guaranteed or consistency cannot be guaranteed, then we do not do updates on actual database, and we ignore changes and we roll back the transaction. But if we check that everything is okay, then we do the actual updates on database, and we go to the third phase, which is write phase. And in write phase, we do updating of database.
Right phase.
So in validation phase, we check TI performs
أبالجيكم.
a validation test. Validation test to see whether it can copy to database the temporary variables that hold the result of write operations. Write operation without causing a violation of serializability. Violation of serializability. So in validation phase, TI check if the updates are done on database, if serializability is satisfied or not. If there is a problem, the updates do not the update do not perform, and we reject and we roll back transaction. But if the check is okay and serializability is okay, and there is no violation of serializability, then we go to the third phase, which is write phase. And in the write phase, the writes are done on database if TI succeeds in validation test, in validation, which is phase 2. Phase 2. Then the actual updates, are applied to database. Otherwise, TI is rollbacked. Okay, so in brief, every transaction has 3 phases: read phase, validation phase, and write phase. In read phase, all the operation of transaction is done except write operation. Write operation are done only on local variables. When transaction has finished, we check in validation phase. We check if we perform updates of transaction on the database. We check if it violates serializability or not. If applying changes does not violate serializability, then we apply changes in the third phase, in write phase. Otherwise, we roll back the transaction. Okay, but how validation test is done? We should say how validation test is done. How we can find applying changes violates serializability or does not violate serializability. Here I explain validation test. Each transaction,
T1 and T2,
each transaction TI has 3 timestamp. In this protocol, in validation test protocol, in validation based protocol, each transaction has 3 timestamps.
receipt,
Start TI, timestamp start TI, which is the time when TI started. The second timestamp is validation. Validation TI, timestamp validation TI, which is the time when TI finished its read phase. And started its validation phase. So it is the time of beginning of validation phase, and it's the time of ending read phase. Validation phase is the time of the time at which the validation phase is beginning. And finish TI is the timestamp when transaction finished its write phase. The time when TI finished its write phase. Okay, so every transaction has 3 timestamps. Start TI, validation TI, finish TI. Okay, now let me explain. The validation test. How the validation test is done. Okay. The validation test for TI, the validation test for TI requires that for all TJ with timestamp TI is less than timestamp TJ, one of the following conditions hold. One. The first condition is this condition. Finish TI is less than start TJ. This means that TI has been finished before TJ has been started. This is the first condition. The second condition is that the second condition has 2 parts. The first part is the set of data items written by TI does not intersect with the set of data items read by TJ and This is the first part of the condition. Second part is that, and finish ti is less than validation of tj. Also, a start of tj is less than finish of ti. Okay. Let me explain validation test more. Suppose we are going to do validation test for a transaction ti. To do validation test for ti, we check all the transaction that has a bigger timestamp. The validation test for ti requires that for all tj with tsti is less than tstj, one of the following condition hold. Either the condition 1 or the condition 2 should be held. The first condition says that ti has been finished before tj has been started. Okay, it is if this condition holds, transaction ti, for example, in the timeline has finished here, finish ti, and then at a point later, transaction tj start. So if this condition holds, ti is completely before tj, and ti and tj are serial with respect to each other. Transaction ti has finished completely, and then transaction tj starts. So ti and tj are serial with respect to each other. So we do not have any problem according to serializability. Timestamp of ti is less than timestamp of tj, and all the operation of ti has been done before all the operation of tj, so the order is okay. The order of execution of operations are according to the order of timestamps of transactions. So we do not have any problem in this case. The second case, this is the first condition. The second condition says that if the first condition does not hold, then we come for checking the second condition. If the first condition does not hold, this means that there is an overlap. There is an overlap between two. There is an overlap between two transactions. If this is the timeline, the finish of ti is not before start of tj. So tj start in some point, start tj, but ti has not finished yet, and will be finished in the later. Will be finished later. So ti is finished after start of tj.
لا يحتاج بالحاسب تخلي 1 9 2 1 6 8 1 خلينا نقول
suppose in this point
ما يصير، لا مو 22، لا بيحطها 25.
TI is finished, and according to this condition validation phase of TJ is later than finish of TI. So in some point later we have validation of TJ. So we have an overlap between TJ and TI. TJ is started here and is continuing. TI has been finished here and has been started before. So we have an overlap in this point. There is an overlap between TI, which is finishing in this point, and TJ, which is started in this point. So there is an overlap between execution of this two transactions between TI and TJ. Okay, timestamp of TI is less than timestamp of TJ. So any conflicting operation of TI should be run before any conflicting operation of TJ. Okay, according to condition 2, we know that validation of TJ is after finish of TI. The write operation of TJ are here. Write operation of TJ, all the write operation of TJ are done on database after validation. When validation test is passed, the write operation of TJ are done on database. So these write operation do not affect TI because TI has been finished before doing this write operation. TI has been finished. So TI cannot read these write operation cannot read the results of this writing operation. So between read operation of TI and write operation of TJ, the order of execution is okay because all the read operation of TI are before all the write operation of TJ. So the order of read operation of TI with respect to write operation of TJ is okay, and timestamp of TI is less than timestamp of TJ, and the read operation of TI has been done before write operation of TJ. So the order between read and write operation of TI and TJ is okay. Also, all the write operation of TI has been done before the write operation of TJ. So also the order of write operations are okay. The write operation of TI and the write operation of TJ. The only thing that remains we check is read operation of TJ with the write operation of TI. There may be some some read operation of Tj here before the write operation of Ti, or there may be some read operation of Tj here after write operation of Ti. Okay, because timestamp of Ti is less than timestamp of Tj, all the write operation of Ti should be done before all the read operation of Tj. But we see that there may be some read operation in Tj that has been done before write operation of Ti. To solve this problem, we add an additional condition. We say that the set of data item that Ti writes does not intersect the set of data item that Tj read, because this read operation, the data item that Tj reads is different from the data item that Ti writes. So there is no conflict between read operation of Tj and write operation of Ti. This is the condition that is stated here. The set of data items written by Ti does not intersect with the set of data item read by Tj. So the order of read operation of Tj and the write operation of Ti does not matter, because there is no conflict between read operation of Tj and write operation of Ti. So anything is okay. Read operation of Tj and write operation of Ti do not conflict. Write operation of Tj are after write operation of Ti. Also, write operation of Tj are after read operation of Ti. So the order of operations, the order of execution of operations are according to timestamps. So anything is okay. So either first condition holds or the second condition holds. Anything is okay, and the order of executions of operations is according to timestamp, and anything is okay, and serializability is guaranteed. So we can let write operation are done on database if any of these two conditions are held. But if these conditions do not hold, then we cannot guarantee serializability, and we should reject transaction Ti, and validation test of Ti does not pass. Is not passed. Okay, I try to explain by pictures, by figures, and I try to explain the details for you to understand why we check these conditions in validation test. Okay, we finish the session at this point. If there is any question, please ask me.
Thank you, Doctor. No question.
Okay, there is either there is no question or all the students are asleep.
No, دكتور.
No, دكتور.
No, دكتور.
No, دكتور.
We just
We here.
are you.
دكتور no.
We just listen to you.
I think I am telling you a story and you are asleep. Okay.
No, doctor, no. We are record this lessons and
Yes.
return to it and focus with you a long time. Thank you, doctor, for everything.
Very good. Very good.
Thank you, doctor. Thank you.
Very good. Be successful.
Thank you دكتور.
Thank you, doctor.
That's a good
Thank you.
Thank you
Have a
دكتور.
nice time. What's up?
Have a nice day. Thank you.
الله.
خدا نگهدار دكتور. خدا نگهدار.
خدا نگهدار.
خدا حافظ.